Bright Duty. Every student matters.
So let us do some of the questions in the exercise here. A drinking glass is in the shape of a frustum of a cone of height 14 centimeter. There is this glass. What is the height of this glass? 14 centimeter. Okay. The diameters of two circular ends are 4 centimeter and 2 centimeter. So radii will be 2 centimeter and 1 centimeter. So this is 2 centimeter, this is 1 centimeter. We need to find the capacity of the glass. So what is the capacity of the glass? Capacity of the glass is nothing but the volume of the given frustum. What is the formula for the frustum of a cone? It is 1 by 3 pi r1 square plus r2 square plus r1 into r2 into h, where h is the height, r1 and r2 are the radii of two circular ends. Okay. So let us put the values directly. 1 by 3 pi can be taken as 22 by 7, r1 square, this is r1, let us say this is r2. So r1 square is 1 square, r2 square is 2 square, r1 into r2 is 1 into 2 into height, which is 14. So this is equal to 1 by 3, 22 by 7 into 1 plus 4 is 5 plus 2, 7 into 14. So this 7 can be cancelled. So this is equal to 308 by 3, and the unit is centimeter cubes. Right. So this is the capacity of this glass here. You can further write it as 1, 0, 2 and 2 by 3 centimeter cubes. 102 and 2/3 centimeter cubes. Okay. The slant height of a frustum of a cone is 4 centimeter and perimeters of its circular ends are these. Find the curved surface area of the frustum. So it has a little twist in the question that the circumference is given for both the ends. So we know the circumference is equal to 2 pi into radius, right. So we will calculate the radii. Let us say this is r1, this is r2. Okay. So for this bigger radii, we can write 2 pi r2, it is equal to 18 centimeter, and 2 pi r1 is equal to 6 centimeter. So we can calculate r1 and r2 from here, and slant height is directly given here, which is 4 centimeter, right. So curved surface area of frustum of cone is equal to pi r1 plus r2 into slant height, which is 4, or let us say, let us write L first to write the formula completely, then we will replace L by this 4 here. So pi is 22 by 7, or you do not have to write pi equal to 22 by 7 here, because what we can do is you need pi r1 plus r2, right. So you can add these two. Let us say this is 1, this is 2. If you add these two, you will have 2 pi as common, r1 plus r2 inside, and it will be equal to 18 plus 6, which is 24. So pi r1 plus r2 is equal to 12. So I'll directly replace this by 12 here. So you don't have to write the value of pi here. So I'll write in this line. So pi r1 plus r2 I am replacing by 12, and L I am replacing by 4 here. So this is equal to 48 and the unit will be centimeter square. So this is the curved surface area of the frustum, right? Fs, the cap used by the Turks, is shaped like a frustum of a cone. If its radius on the open side is 10 centimeter and radius at the upper base is 4 centimeter. So this cap will be of this shape. It will look like a frustum and radius of the upper base is given as 4 centimeter. Obviously this upper base is closed because this is a cap and this is an open face, this one, this is open, okay, and this open side has got radius as 10 centimeter, right. Its slant height is also given 15 centimeter. Find the area of material used for making it. What is the area of material for making it? It is equal to the curved surface area of the frustum part plus area of this upper base, area of the upper base, which is obviously circular, right. So to calculate area of this upper base, right, we just need the radius which is equal to 4 centimeter. So it will be equal to pi 4 square. To calculate the area of this frustum part, curved surface area, pi r1 plus r2 into L, this slant height. So we have got all the dimensions that we need. Curved surface area of the frustum, let me write the formula just for you to memorize it, plus area of the upper base. Let us say this was r1, this was r2. So what will be the area of upper base? It will be pi radius square, okay. L is the slant height which is 15 centimeter here. So just replace these, pi r1 plus r2, so 4 plus 10 into slant height which is 15 plus pi r1 square which is 4 square, okay. So this will be the area of material in centimeter square, alright. So this is pi, this is 14 into 15, 210 plus this is 16. So this is 22 by 7, 210 plus 16 is 226, okay. Now you can calculate it yourself and this will be in centimeter square, right. A container opened from top and made up of a metal sheet is in the form of a frustum of cone. So now this time this container is open from top and closed at the bottom. Okay, and this has got height 16 centimeter. So this height here is 16 centimeter, right, with radii of its lower and upper ends as 8 centimeter and 20 centimeter. So this is 8 centimeter, this is 20 centimeter. All these units are in centimeters, right. Find the cost of milk which can completely fill the container at the rate of rupees 20 per liter. So I need to calculate the volume of this container in liters, then multiply it with 20 to get this answer, right. Also find the cost of metal sheet used to make the container if it costs rupees 8 per 100 centimeter square. For this I need to calculate the area of the metal sheet in centimeter square, then I will do the calculation using the unitary method. Okay. So, I need two things, one the volume of this frustum, second is the surface area. Surface area or the area of metal sheet will consist of two parts, curved surface area of this frustum and area of this base. So, let us first of all look at the easier part, which is the volume of this frustum. It is equal to 1 by 3 pi r1 square plus r2 square plus r1 into r2 into the height. This will be the volume of this frustum. So, it is equal to 1 by 3 into 22 by 7, this is 64, this is 400 and this is 160 into 16. So, it is equal to 1 by 3, 22 by 7 into this is 560, this is 624 into 16, right. So, you can write 208. So, 22 into 208 into 16 by 7 centimeter cubes is the volume of this frustum, but you need the volume in liters. So, as I discussed in the previous question, centimeter cube can be converted into meter cubes by dividing by 100 into 100 into 100, right. So, if I have got 1 centimeter cube, I will have this much meter cube, because 1 centimeter cube is nothing but 1 centimeter into 1 centimeter into 1 centimeter. Okay. So, you can convert this into 1 by 100 meter, 1 by 100 meter, 1 by 100 meter. So, this is how this conversion works. So, 1 meter cube is equal to 1000 liters, right. So, this much meter cubes will have 1 by 100 into 1 by 100 into 1 by 100 into 1000 liters. So, effectively it will be 1 by 1000 liters in 1 centimeter cube. So, to convert it into liters, 22 into 208 into 16 by 7 into 1000. So, this is in liters. Now, we have got a rate of 20 per liter. So, what will be the total cost of the milk? So, cost of the milk to fill this container will be equal to 22 into 208 into 16 by 7 into 1000 into 20, right. So, this will be the cost in rupees. Okay. So, this is the cost of filling this container with milk at rate of rupees 20 per liter. The calculation you need to do yourself. Okay. And we need to find cost of metal sheet now. So, for that we would require the curved surface area of this frustum, and to calculate the curved surface area of the frustum we would require the slant height. Let us name it as L. So, if I drop this perpendicular here, it will be a right angle triangle, right. This side is 16. What will be this side? This will be 20 minus 8, that is 12, right. So, L square will be equal to 12 square plus 16 square, right. So, again you can take 4 square common from it, inside you will have 3 square plus 4 square. Okay. So, L is equal to square root of 4 square is 4, 3 square plus 4 square is nothing but equal to 25, 25 square root is 5. So, 4 into 5, that is 20 centimeter. So, this is the slant height. It is equal to 20 centimeter. Now, once you have got slant height, area of the metal sheet or the area of the container, let us say, is equal to curved surface area of frustum plus area of this base, circular base. Okay, what is the curved surface area of frustum? Pi sum of these radii, which is 8 plus 20 R1 plus R2, right, into slant height, which is 20, plus area of the circular base, which is pi radius square, which is 8 square. Okay, right. So this is how the area of this container can be calculated. It is equal to pi R1 plus R2 into L, which is slant height, plus area of the circular base pi radius of the base squared. So once you calculate this area, you know that per 100 centimeter square it costs rupees 8. So for 100 centimeter square it costs rupees 8. So for 1 centimeter square it will cost 8 by 100 rupees, right. So for this much centimeter square you just need to multiply this by 8 by 100 and you will get your answer in rupees. I hope you understand this. This is the area of the container. Okay, so the 1 centimeter square of metal sheet will cost 8 by 100 rupees and this much area will cost area multiplied by 8 by 100, and this is the calculation part. You do it yourself. All right. A metallic right circular cone 20 centimeter high and whose vertical angle is 60 degrees. What is the vertical angle? If this is the cone, this is the vertical angle here. This angle is 60 degrees. So if I make this axis here, it will divide into two equal parts. So that is 30 degrees each. Now this cone is cut into two parts at the middle of its height by a plane parallel to its base. So it is cut like this, horizontal plane. If the frustum so obtained, so we have got this frustum here, is drawn into wire of certain diameter, find the length of wire. So this question is a combination of two questions. One, the conversion of one shape into another. Second, it is talking about frustum of a cone. Alright, so this metallic circular cone is 20 centimeter high and we have cut it into two parts from the middle part. So 20 centimeter high will be cut into 10 centimeter each, right, and we need to find the volume. Okay, so if I find the volume of this frustum of cone, it will be equal to the volume of the wire that we draw, right. So for that I need to start with calculating the volume of this cone here. To calculate the volume of this frustum of this cone, I need this radius, let us name it as R1, and this radius here, this is R2. Okay, and if you look at this triangle here, this is a right angle triangle, this angle is 30, this height is 10, right, and this is R1, right. So what you can do is you can apply basic trigonometric ratios and you can find the R1. So if I apply tan 30, it is equal to opposite, which is R1, by adjacent, which is 10. Okay, what is tan 30? It is 1 by root 3. It is equal to R1 by 10. Hence I can say R1 is equal to 10 by root 3. Similarly, in this bigger triangle here, where base is R2 and this height is 20 centimeter and this angle is 30 again, I can say R2 will be equal to 20 by root 3. Okay. Or from the similarity concept, you know that if this radius is 10 by root 3, this radius will be double of it, that is 20 by root 3. Why? Because you can compare the heights. This height is 10 and this bigger height is 20. So this radius is 10 by root 3 and this will be 20 by root 3 by the concept of similarity that we used in previous questions. Okay, so we have got radii and we have got the height of this frustum. So volume of the frustum is equal to 1 by 3 pi r1 square, that is 10 by root 3 square, plus r2 square 20 by root 3 square, plus r1 r2 into height. Height of the frustum is 10 centimeters. So I will multiply it by 10. Okay. So this is the volume here, 1 by 3 into 22 by 7. This will be 100 by 3. This will be 400 by 3. Right. So effectively it is 500 by 3 and from here it will be 200 by 3. So 700 by 3 into 10. So this 7 can be cancelled. Okay. So this is 22, 1, 2, 3 zeros divided by 9 and this is the volume in centimeter cubes. Now let us look at the question. This frustum is to be drawn into wire of this diameter. So what is the radius of this wire? Half of this diameter, that is 1 by 32 centimeter, right? And we need to find its length. So this wire is cylindrical wire, right? So volume of frustum will be equal to volume of the wire drawn. Wire is cylindrical, so pi radius square, radius of the wire is already mentioned, 1 by 32. So 1 by 32 square can be written as 1 by 32 into 1 by 32 into length of the wire. So let us denote it by L. Pi r square into height, that is length in this case of this wire. So now the answer is L is equal to 22,000 by 9 divided by pi, which can be written as 22 and 7 can be written here, and this 32 and 32 will get multiplied on this side, right. So this 32 and this 32 get multiplied in 22,000, pi will come in the denominator, which can be written as 22 by 7. So this is the length in centimeters. Okay, you can further simplify it yourself. So this is the length of wire drawn from this frustum of cone. Okay, so this was about this exercise, and this exercise was based on the frustum of cone, where we learnt the formulae for volume and surface area, curved surface area of the frustum of cone, and how to calculate the slant height of the frustum of cone. In the next exercise, we will discuss some of the miscellaneous questions based on the same exercise, and in the next exercise, I will also derive the formulas for volume and surface area of the frustum of cone. Okay, thank you.